According to the National Electrical Code Section 702.5, an individual disconnecting means must be installed ahead of each automatic transfer switch, or ATS, other than those provided in Section 702.5C2. This requirement is in place to ensure safety and provide a way to de-energize the ATS and downstream equipment for maintenance or in case of emergencies. Now let's delve into the exceptions mentioned in NEC 702.5C2. An ATS does not require an additional disconnecting means if it firstly is intended for use as service equipment, secondly has a combined interrupting rating sufficient for the application, and thirdly is approved for installation as a service disconnect. These exceptions are crucial to understand because they can impact the design and installation of your system. Firstly, if the ATS is intended for use as service equipment, it inherently includes service-rated features and is designed to handle the fault currents and overcurrent protection requirements associated with service entrances. Therefore, an additional disconnecting means may be redundant. Secondly, the ATS must have a combined interrupting rating sufficient for the application. This means that the ATS, along with any upstream overcurrent protective devices, must be able to safely interrupt the available fault current at the point of installation. This is a critical safety consideration to prevent equipment damage and potential hazards during short circuits or ground faults. Thirdly, the ATS must be approved for installation as a service disconnect. This approval indicates that the ATS meets specific standards and is suitable for use as the main disconnecting means for the service. If the panel board is not being used as service equipment, you will need an additional disconnecting means ahead of the ATS. This disconnect can be a circuit breaker or a switch, but it must be readily accessible and clearly labeled to indicate its purpose. The purpose of the disconnecting means is to provide a way to isolate the ATS and the downstream panel board from the power source, allowing for safe maintenance, testing, and troubleshooting. This disconnecting means should be located in a readily accessible location, ideally near the ATS, so that it can be easily reached in case of an emergency. Proper labeling is also essential to identify the disconnecting means and its function clearly. The disconnecting means should be rated for the available fault current at its location. This rating ensures that it can safely interrupt any potential short circuits or ground faults without causing damage to the equipment or posing a safety hazard to personnel. It's important to coordinate the overcurrent protection devices upstream of the disconnecting means to ensure proper selectivity and coordination. Selectivity means that the upstream device should only trip if the downstream device fails to clear the fault. Coordination ensures that the overcurrent protection devices work together to minimize the impact of a fault and prevent unnecessary power outages. The size of the conductors feeding the ATS and the disconnecting means must be properly sized according to the National Electrical Code NEC requirement. The conductor size should be based on the ampacity of the load served, taking into account any directing factors for ambient temperature or conductor bundling. Grounding and bonding are also crucial aspects of the installation. The ATS and the disconnecting means must be properly grounded and bonded to ensure a low impedance path for fault current to flow back to the source. This helps to minimize voltage rise during a fault and facilitates the operation of overcurrent protection devices. It's essential to follow the manufacturer's instructions and the NEC requirements for grounding and bonding to ensure safe and reliable installation. The disconnecting means should be inspected and tested regularly to verify its proper operation. This includes checking the condition of the contacts, the integrity of the enclosure, and the proper operation of the switching mechanism. Any issues or defects should be addressed promptly to prevent potential problems in the future. In summary, when feeding a panel board with a main breaker through an ATS switch from a different building, you typically need an additional disconnecting means ahead of the ATS, unless the ATS meets the exceptions outlined in NEC 702.5C2. This disconnecting means provides a critical safety feature and allows for safe maintenance and troubleshooting of the electrical system. By understanding the NEC requirements and following best practices for installation, you can ensure a safe and reliable power transfer system. Furthermore, consider the implications of the type of load being served by the panel board. If the panel board supplies essential loads such as emergency lighting, fire pumps, or critical medical equipment, the reliability of the ATS and the disconnecting means becomes even more crucial. In such cases, it may be advisable to implement redundant systems or additional monitoring and control features to enhance the overall reliability of the power transfer system. Also, the specific requirements for disconnecting means may vary depending on the local electrical codes and regulations. It's always a good practice to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. A qualified professional can assess the specific installation conditions and provide guidance on the appropriate disconnecting means and other safety measures. In addition to the NEC requirements, consider the operational aspects of the ATS and the disconnecting means. Ensure that the disconnecting means is easily accessible to authorized personnel and that it is clearly labeled with its function and the equipment it serves. This will facilitate quick and efficient response in case of emergencies or maintenance activities. Furthermore, implement a regular maintenance program for the ATS and the disconnecting means. This program should include periodic inspections, testing, and cleaning of the equipment to ensure its proper operation and prevent potential failures. The maintenance program should be documented and records should be kept of all inspections and maintenance activities. Consider the use of surge protection devices to protect the ATS and the downstream equipment from voltage surges and transients. Voltage surges can damage sensitive electronic components and disrupt the operation of the power transfer system. Surge protection devices can help to mitigate the impact of voltage surges and improve the overall reliability of the system. Another important consideration is the coordination of the ATS with the generator or other alternate power source. The ATS should be designed to seamlessly transfer power between the normal source and the alternate source without causing any interruption to the load. This requires careful coordination of the voltage, frequency, and phase angle of the two sources. Regular testing and maintenance of the generator and the ATS are essential to ensure proper operation and prevent potential problems during power outages. It is also crucial to ensure that the ATS is compatible with the type of generator or alternate power source being used. Different types of generators may have different requirements for voltage, frequency, and control signals. The ATS should be designed to accommodate these requirements and provide seamless transfer of power between the two sources. In addition to the technical aspects, consider the human factors involved in the operation and maintenance of the ATS and the disconnecting means. Provide adequate training to personnel who will be operating and maintaining the equipment. The training should cover the proper procedures for starting, stopping, and transferring power between the normal and alternate sources. It should also cover the safety precautions that must be taken when working with electrical equipment. Develop clear and concise operating procedures for the ATS and the disconnecting means. These procedures should be readily available to authorized personnel and should be reviewed periodically to ensure they are up to date. The procedures should include instructions for normal operation, emergency operation, and maintenance activities. Conduct regular drills and simulations to practice the operating procedures and ensure that personnel are familiar with the equipment and the procedures. This will help to improve response time and minimize the impact of power outages. Consider the use of remote monitoring and control systems to monitor the status of the ATS and the disconnecting means. These systems can provide real-time information on the voltage, current, frequency, and other parameters of the power transfer system. They can also provide alerts and alarms in case of abnormal conditions. Remote monitoring and control systems can help to improve the reliability and efficiency of the power transfer system. The type of disconnecting means used can vary depending on the application and the specific requirements of the installation. Some common types of disconnecting means include circuit breakers, fused disconnect switches, and non-fused disconnect switches. Circuit breakers provide overcurrent protection in addition to disconnecting the circuit. Fused disconnect switches provide overcurrent protection using fuses. Non-fused disconnect switches provide a means of disconnecting the circuit without overcurrent protection. The choice of disconnecting means should be based on the specific requirements of the installation, including the available fault current, the ampacity of the circuit, and the need for overcurrent protection. The disconnecting mean should be sized appropriately for the ampacity of the circuit it serves. The ampacity of the disconnecting mean should be equal to or greater than the ampacity of the conductors feeding the ATS. The disconnecting mean should also be rated for the available fault current at its location. The fault current rating of the disconnecting mean should be equal to or greater than the maximum fault current that could occur at that point in the system. Proper labeling of the disconnecting means is essential for safety and ease of operation. The label should clearly indicate the function of the disconnecting means and the equipment it serves. The label should be durable and weather-resistant to ensure it remains legible over time. The location of the disconnecting means should be readily accessible and clearly marked. The disconnecting means should be located in a safe and convenient location where it can be easily reached in case of an emergency. The location of the disconnecting means should be marked with a sign or label to make it easy to find. Regular inspection and maintenance of the disconnecting means are essential to ensure its proper operation. The disconnecting means should be inspected periodically for signs of damage or wear. The contacts of the disconnecting means should be cleaned and lubricated as needed. The disconnecting means should be tested periodically to verify its proper operation. The testing should include verifying the continuity of the circuit and the proper operation of the switching mechanism. Any repairs or replacement should be performed by qualified personnel using approved parts. It's important to keep accurate records of all inspections, maintenance, and repairs performed on the disconnecting means. These records can be used to track the performance of the equipment and identify potential problems before they lead to failures. The record should include the date of the inspection or maintenance, the name of the person who performed the work, and a description of any repairs or replacements that were made. In summary, the selection, installation, and maintenance of the disconnecting means are critical to the safety and reliability of the power transfer system. By following the NEC requirements and best practices for installation and maintenance, you can ensure that the disconnecting means will perform its intended function safely and reliably.